now. Okay. Good afternoon, everybody. It's 1300. We're going to start the webinar. Um, this is the Society of American Military Engineers Environmental Community of Interest Industry and Government Engagement Project webinar, PFAS Sampling Considerations in Analytical Chemistry. I'm your moderator, Rick Weiss with Patel Memorial Institute. This is the third in a series of presentations we're doing as part of the PFAS IGE. We had an overview as an introduction. We had a PFAS 101, and this is going to be on PFAS sampling considerations, analytical chemistry. This is one of a series of webinars we're going to be having over the next year and a half to 2 years on PFAS. We'll also shortly be publishing fact sheets that'll be available summarizing the content of each webinar. Okay, so some housekeeping tips here. If you're on a VPN, that could be a little bit of a problem. So log back in if you can. If it's knocking you in and out. Please use the chat tab for technical issues only. We will be submitting written questions submitted by the Q&A tab. I will be looking at those and we'll be holding questions till the end of the webinar. There's also, if you look on the right-hand side of your screen, you should see a tab for handouts. A PDF of this presentation is available for you to download. Okay. We're also recording this webinar for future reference. It will be posted to the SAME Environmental Community of Interest website. It's pretty easy to find. If you go to same.org and you look at the sub-tab, how to get involved, and scroll down, you'll find the communities of interest. We're also building a IGE, a PFAS IGE website, and the big plan for SAME is to upgrade the whole website architecture to make it easier for you as a consumer of the information. Okay, here's a quick poll question. We'd like to know who we have in the audience here. The classical categories of SAME members, active duty, large business. So if you can do that, we'd love to know who's attending today's poll. Okay. Give you a minute for that. And now I'll move on. Okay. So like I mentioned, I'm Rick Weiss with Patel Memorial Institute. I am the chair of the Environmental Community of Interest, and I'm moderating today's event. Just a point to note here that Bill Giuseppe of Jacobs is the project manager for this IGE effort. Today we have two speakers, and I'll introduce them in the order of presentation. Or actually, John, you're going first?
Yes.
Okay, so let me do that in the order of presentation. So basically, our first presenter, and this is going to be both gentlemen presenting, is John Powell with Salis O'Brien. John's been involved with PFAS projects for over 6 years. He supported PFAS drinking water mitigation, site investigations, remedial investigations, and monitoring projects for DoD, NASA, and US EPA. He's also been active on a startup team responsible for laboratory validation, study of method 1633. He's also a member of the ITRC PFAS team, and he's one of the key members of our SAME PFAS IGE. He's a program manager at SIA, and we'll be hearing more from him in a few minutes. Our next speaker is Osaguana Bebar. I hope I got that right. And Osaguana has been involved with site investigation, remedial investigations of sites where PFAS is a concern for over 6 years. He supported projects for the DoD and EPA. He's also a member of the SAME PFAS IGE, and as a senior geologist with EA Engineering, he supports the PFAS projects for DoD and US EPA. So with that, I'll go to the agenda here real quick. So we're going to start off with an introduction to PFAS chemistry, some of the key elements that make PFAS sampling different from other sampling events, some of the best practices, the current state of PFAS analytical methods, which has just changed a little bit, so this is going to be up-to-date information, and some background chemistry on PFAS and PFAS analysis. So with that, I'm going to turn it over to our first speaker.
Thanks, Rick. Well, to start with today, I'd like to briefly touch on some items that were covered in the last PFAS presentation. PFAS, as you can see here, are a group of chemicals with over 4,700 individual compounds. And there are polymers and non-polymers. And polymers generally aren't a concern to human health and the environment. However, non-polymers are used in the manufacture of polymers, and the most well-known of these are PFOA and PFAS. So within the non-polymer group are perfluoroalkyl substances and perfluoro and polyfluoro, I should say, alkyl substances. Per means that the group is fully fluorinated, where poly means that the compound is partially fluorinated. And we'll see that later that this will make a big difference in the behavior of these two different groups. And here we can see that the individual PFAS are named based on the number of carbons in the chain. So examples of this are 4 carbons. So that top one there is buta. So perfluorobutanoic acid has 4 carbons, and 8 carbons equals octa. Therefore, perfluorooctanoic acid has 8 carbons. And there's a diagram here of perfluorooctanoic acid, which is also called PFOA. In this diagram, we see the 8-carbon chain. We also see an important item here, so which will become relevant as you get into fate and transport and particular treatment, is there's a head, which is a functional group, charged functional group, and a tail, which is the fully fluorinated group. Next slide. And so now with this little formula here, and then we can quickly start assembling the names and the acronyms of the perfluoroalkyl acids using this simple system, where PF equals perfluoro, X equals the number of carbons in the alkane tail, and Y is the can either be S for sulfonate or A for carboxylate. For example, an 8-carbon chain, octane, with a sulfonate group becomes perfluorooctane sulfonate, or PFAS. One important thing to note is we count all of the carbons when naming the carboxylates. So even though PFOA has 7 carbons in its tail, we include the carbon in the CO2, that end there, so, or head, for a total of 8 carbons. The concept of a head and tail, again, will become more important as we get into treatment and fate and transport. Next slide. So which PFAA or perfluoroalkyl acid are we talking about? So sometimes there's confusion on if it's the acid or the anion. And some PFAS can exist in the environment in various ionic states, acids, anions, cations, or even what are called zwitterions, which means they're both positively and negatively charged. And the charge on the molecule has an important implication for their chemical and physical properties, and also, again, the fate and transport and treatment. But perfluoroalkyl acids are almost always present in the environment only as a negatively charged anion. However, your laboratory will likely report the PFAAs, or perfluoroalkyl acids, as acids in their reports, even though they're present in the environment in the anionic form. Why is this? It's because in the United States, the EPA method and the DoD require that these be reported, so there's consistency among all the laboratory reports. The other major class of PFAS that we need to be concerned about are the polyfluorinated substances. So these PFAS have at least one non-fluorine atom attached to one or more, but not all, of the carbon atoms in the alkane tail. This is important because these non-fluorinated bonding sites create a weak link in the chain that is susceptible to biotic or abiotic degradation. As a result, some polyfluorinated PFAS may be able to degrade to form a more recalcitrant PFAS, or perfluoroalkyl acids. Some polyfluorinated PFAS you may be familiar with include the fluorotelmer sulfonates or fluorotelmer alcohols, which are often detected at sites where there's aqueous film forming foam, or AFFF. Those PFAS have names with a prefix of 6,2 or 8,2 or other numbers in front of them. These numbers tell you how many carbons in the tail that we referenced earlier are fully fluorinated and how many are not. This in turn can indicate the maximum number of carbons that may be in the alkene tail of a resulting PFAA that forms when this, what's called a precursor, degrades. So degradable PFAS are often referred to as precursors, and PFAAs that degrade are sometimes referred to as what they refer to as terminal PFAAs. It's important to note that once PFAA is formed, regardless of its chain length, it will not readily degrade further. PFOA will remain PFOA. It will not break down to a shorter chain PFAA in normal environmental conditions. And this slide shows some of the major precursor PFAS groups and whether they have the potential to break down to what are called PFCAs, PFSAs, or both. And this is only a partial list. The identification of precursors is an ongoing area of research. And now I'll turn it over to Osaguana to talk about PFAS sampling considerations.
Thank you very much, John. Thank you, John. As you may have heard or be aware, PFAS sampling presents a lot of challenges because of their nature and because of the very low expected level of detection and reporting. So because of that, there's a lot of concern with possible cross-contamination as sample bias, and there's a lot of things that result bias, and there's a lot of things that could affect the result. So one of the things that we take very important or that is highly advisable is making sure that the sampling program match with what is expected. A good QAP plan or work plan is one of the best ways to make sure that the result that you are getting is representative of what is expected. And we have a table here because of the nature of PFAS. There's a table here on slide 16 that brings some of this material that should be avoided during sampling, and some that has been proven not to be as problematic as they were thought at the beginning of this of the science of PFAS. So some of these things is an evolving table. Things are coming in, others are being ruled out as things that people should be concerned about. But the more you know about it and work this into your plan, whether that being the QAP or the work plan, the better for you and the planning team when it comes to considering what to use in the field for sampling. One of the things that we recommend, I highly recommended, is making sure that the equipment, the source of the equipment, is well understood, and taking equipment sample, rinse blank, to make sure you are ruling out cross-contamination from the materials that you are using for the sampling. And whatever you do, make sure proper documentation of field activities and field event helps a lot, so that if they are looking at, somebody is looking at the result later, probably looking at where some bias or some influence may have come into the result, they'll be able to look back and look at the documentation helps in that regard. Right now, some of the things that that we'll look at here, the overarching objective of the project, knowing where PFAS or high concentration of it may be encountered, is something that that must be taken into consideration while planning for the sampling. Understanding the site conceptual model, understanding where high concentration of PFAS may be found on site, understanding the site history, all those things will play into the sampling planning. Because if you know, maybe there's a fire training station that was on site, for example, where there might be high potential of concentration for PFAS, then you pay more attention to your decom process, and maybe collected blank samples after the contamination to make sure there is no sample interference. Understanding where these things are and the site history and the site conceptual model will go a long way in planning your sampling protocol and doing it the right way. And having a good SOP and plan that is developed will help also. There are several there, depends on the program you are working on. Even internally within your organization, there may be a plan that has been developed that will address some of these concerns that we are talking about here, to make sure that the sample you are getting or you are collecting is representative of the site condition. All right, so some additional consideration here that we're looking at, you must talk to the lab. Make sure the lab understand your sampling objective and what you are looking at, because it's not like a traditional or other contaminant that you're looking at. The lab, making the lab being part of the program, understanding what is going on here, will help a lot in deciding or planning or having a successful plan when it comes to sampling. For example, they're looking at sample volume depending on the method that we're looking at. As you can imagine, there are several methods out there. We'll be talking about that here. John will be going back, looking at some of these methods here. So there are sample requirements for each of these methods and also different reporting levels. So letting the lab know what your plan is and running your sampling plan by them, they will be able to help you plan this out very well. And make sure the requirement, what you need in the field, is well taken care of, and make sure the laboratory knows what you are expecting as far as the concentration. Because some of the method here, especially the, for example, the draft 1633 method required the lab to screen the entire sample that you submit to the lab. And so that may require you to collect additional volume of sample. So the more you let them know ahead, the better it will be for them to send you the required things that you required and what they will need to carry out the analysis. All right, some sample supplies here are some of the material that is being recommended to avoid, either because they introduce bias, they introduce some into the result, or maybe they have the potential to absorb PFAS from the sample. We have a list of it here. This is not an exhaustive list. As you can imagine, the science is still developing. We are knowing more about this PFAS and some of the samples that some of the material that has been thought to be an issue is we're coming to more understanding. For example, the Michigan Eagle, they have a very good program, a very good guidance that rule out some of the sunscreen and some of the bug spray that people used to think to avoid when considering sample. I remember years ago, it was don't touch it, don't touch it. But now you go to that Michigan Eagle, you go to their program, for example, they have a list of those material that they've taken to the lab and they've tested and proven to be very, very safe to use for PFAS sampling. So this is a list, not a comprehensive list, some of the material to avoid and some that you can use during a sampling event. This is a table that we're talking about. This is a list of some material to use and others to avoid. This is not a comprehensive list, and maybe because of the presentation now, you may not be able to read this table as it is on the screen now. But when you print it out, maybe in the handout later, you see some of them that you see the material that has been recommended and others that have been advised to stay away from when it comes to this sampling for PFAS. Like I said, this is a growing list. It's an evolving list. With every day as the science develop, more materials are beginning, can go either way, either the recommended or the stay away from category. I think that was one slide too many. Now, what is one of the things that everybody should pay attention to is whatever material or equipment that is being used or planned to be used here, understanding the content or the composition of that material helps a lot. And one safe place to go is the safety data sheet to see if PFAS is included as one of the things or even in the process of making that equipment. The fact that the safety data sheet does not state that PFAS is present in the equipment or material will not rule it out. So even when the safety data sheet is not part of the process, that does not automatically rule it out, because even in shipping it or bringing the equipment to your warehouse or to the field or the packaging, it may have come in contact with other things that may have PFAS in it. Because of where the nature of PFAS is all over, it's everywhere. So the first thing is to err in the side of caution, assume it's there, and be very careful and make sure some of this material does not come in contact with the sample, and also the personnel that are conducting the sample or even in the staging area. But when in doubt, when you are not sure, run that piece of equipment or material by the lab. Take a sample, a rain sample or a wipe sample, send it to the lab, and they will help you test it and make sure they rule out the presence of PFAS before you can use it. All right, what to do if you are not sure or if you are unsure that the item that you are talking about contain PFAS. Like we said, you look at the safety data sheet. That's the first place to start. And if it is not clear from there, call the manufacturer. They will be happy to talk to you about it and inquire about the process. How did they get to where they are? What did they use? And even the packaging, ask questions about the packaging and how these things were shipped to you. And be sure that it is PFAS free before you employ any of these material for your sampling event. Then if most guidance, like we talked about, most guidance are out there that are very specific on what you can use and what you cannot use. Make sure you refer to this guidance, know the program that you are working on, and use the guidance that the program recommend, and talk to within your organization. Like we said before, there should be somebody that is familiar with this process, that is familiar with PFAS and have worked on the project or knows what is going on. Talk to them, and they'll be able to give you some guidance on how to address this concern. Then the lab or analytical chemist, either within your organization or in the lab, will be another resource that you can talk to. Tell them what you're doing and the material that you are using. And like I said before, if you're not sure, a piece of that equipment or a piece of that material going to the lab for analysis will rule out any source or any presence of PFAS even before you use it. Now, the other thing that we look at that could be a source of concern is the sample container. Sometimes the sample container could be method specific. For example, if we are looking at the method 537-1, there are containers that you can use, and the lid, the material that the lid is made of, so if you look at another method 533, it allows for the use of polypropylene and for the container as well as for the cap. So make sure the method that you are using, understand the method, understand the restriction, and the lab will definitely help with this method, with this selecting the sample equipment or container. So tell them what your project goals, what your objective is, and the method that you are trying to run. They will send you and make sure they ship the right containers to you. All right, so there are some methods that require all the whole sample of that you collect to be analyzed, and even the rain sample from the container to be the rain set to be analyzed. So it is always a good idea you talk to the lab, know the method that you are applying, and so that when you send this sample to the lab, they know what to test for. And one other thing here that maybe as consultants we may not be dealing with here is AFFF, the requirement for the test, even the diluted form, the concentrate that that DOD are studying now. So if you are dealing with that, which is not something that maybe the consulting side of the house that we deal with, but if that is what you are doing, make sure the lab knows and make sure you collect enough sample and have the right sample container for that. All right. So like we said, is the lab is the place to go to. Make sure they have this the material that you are using, understand it, and even some reagent that you use in the field, your Deacon solutions, solvent that you use in the field. Make sure they test it and they report it to you as PFAS free before you can use it. Even some waters, Deacon water that you use or water that you use for your QA/QC sample, make sure they test it and it's PFAS free. And if you have to take sample from site, it is advisable that you don't use sample from site. You get the water from the lab. But if you have to use water from site, send a sample of that to the lab before you use it. It is advisable to get all your water sample from the lab so that it's tested as and confirmed to be PFAS free before you use it. All right. So for the sample preservation and shipping, it differs for each method. Depending on the method, we have a table here. I think that's the next slide or thereabouts, where you have the whole time, the shipping time for each of the sample, depend on the method that you are using. Then that would determine the preservative that you use, as well as the shipping time. All right, so hold time for some of these samples for the method. If you are looking at method 537-1, you can you have 14 days to extract and 28 days to analyze. And for different method, the draft method 1633, you have some leeway there, up to 90 days to extract or analyze if the sample is frozen. If it's just refrigerated, you have 28 days to extract and to analyze. So the key takeaway here is it depends on the method that you are using. Understand the method, which should be spelled out in your sampling plan, and know when and how to get the sample to the lab so that it's within all time. Now for field documentation or the decontamination, any equipment that you are going to reuse in the field has to be properly decontaminated. But there are some, like we said, it's not like sampling for PFAS, it's not like sampling for any other contaminant. So there are the detergent and soap that we are used to using in the field. Some of them have the fluorosulfurants that you cannot use for PFAS sampling. So know the content of the soap or the decontamination fluid that you are using, and make sure it is free of PFAS. Sometimes we may have to deal with decontaminating the heavy equipment, like a drill rig, for example. Having the lab ship enough water that you're going to use to decon a heavy equipment like that could pose a challenge. So you may have a proper decon method that you can use to clean the equipment, then have a sample that or PFAS-free water that you can just use to rinse a part of the equipment that may come directly in contact with the sample. So it's planning. Know what you're doing and have a plan to make sure that you keep your sample clean and of high integrity before during sampling. All right, the lab will help in getting you a PFAS-free water for your final rinse. Like we said before, if you have to use water from another source that is not supplied to the lab, make sure you get a sample of that water to the lab, you test it and confirm it to be PFAS-free even before the sampling event starts. Or if you have to use it, make sure you take a sample of it and ship it with your sample to the lab so that they know what you are using while you are out there. Now, for the field quality controls, there are a requirement on the number of QA/QC sample that you can collect, but it's recommended that one field reagent blank for each set of samples per site, and a field duplicate is collected for the sampling event. Then the frequency and the field duplicate has to be specified in your plan. But it is recommended that one extraction batch does not exceed more than 20 field samples. All right, so the collection frequency has to be something that you understand and is documented in your field document, so that in your field note, so that they know how often you are collecting your samples. Sometimes additional quality control sample may be needed based on the site condition, especially if you're dealing with areas of high concentration. Like we said before, maybe a fire training area, for example, where you expect the concentration to be high. So you might need to collect more equipment blank to show that your decom process is thorough. So this is a slide here. We're talking about some QA/QC samples and talking about the pre-investigation equipment blank, like we talked about. Decon water that you're going to use, make sure it's tested before you start. You know what the source of the water and that is PFAS free before you use it. Your methanol for cleaning, new equipment that you've not used before, plastic bag that is coming to the site, sample containers, anything that you are not sure of, make sure it's tested before the investigation start. And during the investigation, equipment blank to demonstrate that the decom process is thorough. Field blanks to make sure that there is nothing that is introducing PFAS into your samples while in the field. Field reagent that you are using in the field, test it and make sure it is free of PFAS, and treat blank to make sure that nothing is introduced while the sample is in transit to the lab. Now, one challenge that people have, that PFAS pose, is when it comes to filtering the sample. The simple thing is, if you can, don't do it. Don't filter. Send it to the lab, and the lab will filter it. And but if it's absolutely necessary that you have to do it, you can't get away from not doing it. Make sure that the filter that you are using is tested. Send it to the lab before you use it, and consider using low flow. Maybe that will cut down the turbidity and maybe get you to a point that you may not need to filter. But if you have to, get it to the lab. Let the lab be your first choice to do the filtration. And if you cannot, make sure all the filters and all the material you are using for the filtration is tested before you start the event. All right, I'm going to turn it back to John now for the PFAS analysis.
Thanks, Osaguana. All right. The two most common EPA methods that have been referenced in the past and everything so are EPA 537.1 and then EPA 533. These two EPA methods are applicable to drinking water, and the analysis of drinking water samples in particular will come into play for EPA has what's called the 5th Unregulated Contaminant Monitoring Rule. And that will start up next year. The Safe Drinking Water Act requires once every 5 years that EPA issue a list of unregulated contaminants to be monitored in public water systems. And UCMR 5 is going to require the analysis of 30 new chemical contaminants between the years of 2023 and 2025. And most of those new contaminants are PFAS. These two methods have a number of similarities. As we can see, the sample preparation between the two uses the same technology, what's called solid phase extraction. They both have compound-specific analysis using same instrumentation, liquid chromatography, and tandem mass spectrometry. And the laboratories are allowed some modification, but they cannot change things such as sample collection and preservation, that Osaguana went over earlier, the extraction technique, and the quality control requirements. And both of these methods are multi-laboratory validated methods. And here we see the list of analytes that are covered by these methods. And on the middle there, we have the compounds that are covered by both analytical methods. And to the right, EPA 533 covers those compounds only, where 537 covers only those 4 compounds to the left. So those 4 are unique to 537. And then we have, as I mentioned, the ones that are unique to 533. So with the UCMR 5 or drinking water analysis that'll be coming up here, then the use of both methods is required. And some think that this list of analytes will most likely move forward with the analysis of other matrices as well, using different methods. But that is yet to be determined. And the new method that's entered recently is Epa Draft Method 1633. This was first published so recently in the last year or so, and it's a single laboratory validated method that was finished in August of 2021. This uses a different method of quantitation called isotope dilution than some of the other methods. But again, it is a compound-specific analysis, and it has 40 different PFAS analytes in it. One thing that differentiates this method from others is that, as opposed to like 537, 533 that only are applicable to drinking water, this covers all the other matrices that are of typical environmental concern, such as groundwater, surface water, wastewater, leachate from landfills, biosolids, tissue samples, sediments, and soils. There are currently 5 laboratories that are DoD ELAP accredited for draft EPA method 1633. And this method is currently undergoing a multi-laboratory validation with 8 commercial laboratories and 2 state laboratories. And the reason that it's important also is the number of laboratories that are certified or accredited for this is that DoD issued a memo at the end of last year that requires that all new contracts or task orders must utilize EPA Draft Method 1633 for the analysis of PFAS. Another method that is utilized but not as frequently is for the analysis of air or air particulate, and it's US EPA Draft Other Test Method 45, also referred to as OTM 45. And this is used for the measurement of PFAS in basically air and off-gas samples. This method was released last year, and it contains 50 PFAS analytes, and again uses the same technology, so liquid chromatography, tandem mass spectrometry. And this method has a lot of detail, including the requirements for sampling, sample preparation, as well as the analytical procedure. And this method is not performed by very many commercial laboratories whatsoever. And so it can cost as much as $10,000 per sample. Let's see, and with EPA method 8327 was released last year. It also covers 24 PFAS analytes and uses the same technology, liquid chromatography, tandem mass spectrometry. But it does not include all the PFAS that are listed in EPA 537 or 533 that we mentioned earlier. It is applicable to groundwater, surface water, and wastewater, but the DoD has determined that this method is not capable of achieving the required data quality objectives. So therefore, DoD considers this to be a screening method and should not be used to collect definitive data. That's an important note there, because you don't want to use that if you're requiring definitive data for your remedial investigation or something like that. DoD AFFF-01 is another method, but it uses, again, liquid chromatography, tandem mass spectrometry, but it's for PFOA and PFAS only. And that's because this method is for the analysis of AFFF concentrates for compliance with the mil spec for AFFF. That method may be come into play more in the near future as DoD goes through the various bases and requires the replacement of AFFF with different AFFF that hopefully doesn't contain PFOA and PFAS. And then we have other published methods that are available out there from the International Standard Organization, the American Society of Testing Materials, the FDA, CDC. These are not commonly used in environmental analyses, but you may see them out there. So some key method differences between all of these different methods are basically the media or the matrix that's impacted. And as we mentioned, so 537.1, 533 are for drinking water. 1633 holds promise because it'll apply to all of the typical environmental matrices, including groundwater and surface water, which are often analyzed. So, and another difference is the limit of detection and quantitation. And that is going to be a challenge, especially with the new drinking water health advisory limits that were issued last week. For the first time, the limits were established for Gen X and PFBS. So, and there are interim limits that were established for PFOA and PFAS as well, that were greatly reduced over the previous limits that were established. And while the limits for Gen X and PFBS are attainable using the current drinking water methods and other methods, so the limits for PFOA at 0.004 parts per trillion, or 4 parts per quadrillion, and PFAS of 0.02 parts per trillion. So those limits are not readily attainable by most laboratories. And these new limits were published in the Federal Register just this past Tuesday. So there'll be quite a bit of a challenge for what's going to be done with those new limits and if they'll be required for drinking water or other matrices. So, and then another thing that's different between the analytical methods are the method analyte list, and also with respect to the individual analytes, what's called the isomeric profile of the individual analytes. And we'll see here what we mean by that isomeric profile. So PFOA and PFAS, as well as many of the other PFAS, are present actually in what are called branched and linear isomers. The linear isomer is the predominant isomer, but also then you have branched isomers that were formed during the production of the various PFAS. And especially with what's called ECF, or electrochemical fluorination, and as we can see here, about 22% of the end product was in the form of branched isomers, where 78% was in linear isomers. And we can see here just a little illustration of things. So whenever the chromatography, that the linear isomer is the predominant isomer, where branched comes out before it, and it's there to a lesser extent. But where this is particularly relevant, if you're looking at historical data, not all of the methods quantitated these in the same way. So you need to pay particular attention to this, or you could actually be biased low by approximately that 22% or so. And as far as data validation and review guidelines, without proper review or validation by the PFAS method, analytical data generated by those methods, the usability of the data cannot be readily evaluated. The EPA has published for guidance for the review and validation of PFAS for drinking water, as we can see that first one there. And it has also published a technical bulletin which outlines general principles for PFAS data review. And DoD has data validation guidelines for PFAS, utilizing the DoD Quality Systems Manual, what it's referred to as Table B15. And DoD is currently in the process of writing data validation guidelines for data generated using EPA method 1633, which is currently in the DoD QSM Table B24. However, there are no currently published EPA review or data validation guidelines to evaluate LC-MS data for non-potable water or solid media. So it's particularly important there that the other data validation guidelines are referenced, or that you make sure that you do not use other technologies such as GC mass spec, which is commonly used for the analysis of BOAs, and try and make that applicable to LC mass spec data. And then there are a number of non-standard analytical methods that you may see in literature out there, and some folks may talk about for screening. Particle-induced gamma emission, which is referred to as PIGY spectroscopy, does basically a total fluorine analysis. Precursor analysis, which is by total oxidizable precursor or TOP assay, basically is going to help analyze for those perfluoroalkyl acid precursors or the polyfluorinated compounds that can be converted to the PFAS or the perfluoroalkyl acids through oxidation. And that can, again, help with the analysis for fate and transport. And then LC quadrupole time of flight mass spectrometry, which is referred to as QTOF, helps also with the analysis of these non-standard compounds. And then a recently released method by EPA is for absorbable or extractable organic fluorine, where it measures fluorine in a sample as fluoride. And again, that's used for a screening technique. So the takeaways here we have for the analysis are there are a number of different PFAS analytical methods that are published, and there are significant differences between them, and those need to be evaluated when selecting a method in order to make sure you achieve the proper DQOs or data quality objectives. Additional analytical methods are currently in development, and there are a number of them that will be released in the near future. Less standardized analytical techniques that can be helpful for qualitative or screening tools, such as we just referenced PIGY or the absorbable organic fluorine. So much of the information today that was presented today can be found in the ITRC, or the International Technology and Regulatory Council, PFAS technical and regulatory guidance document. And I encourage you to refer to that if you want to research these topics more or learn other things about PFAS. And with that, Rick, I'll turn it back to you.
Let me come off mute here and get back online. Thank you very much. Great presentation. We have a couple of questions here, and we have time if people want to send a couple more in. You know, John, earlier you mentioned precursors and PFAA degradation to different compounds. What causes that degradation? What's going on?
Let's see, the precursor compounds, as we saw back in one of the earlier slides, has the fully fluorinated section, and then there's a not fully fluorinated section. So those are referred to as the polyfluorinated compounds. And where you break over to the non-fully fluorinated section there, then those can be oxidized, or actually with like wastewater treatment plants, one of the issues that they see is that it goes through the regular, say, the bug pond there, so with the abiotic or biotic degradation, and the precursor compounds will actually be degraded during that process. So you'll have one level of PFO or PFAS coming in, and you'll actually have a higher level leaving. So, and that's a problem with not only with wastewater
also
treatment
occur?
plants, things like landfills. So treatment processes for groundwater can have the same problem.
Okay, yeah, that's what I was thinking, because a lot of landfills have a lot of PFAS issues with it there. Another question came up. This is from Jim Carter. And he's asking here, isotope dilution has some distinct advantages, especially in determining concentrations of contaminants with a high degree of accuracy. However, it's a high-cost method, lacks flexibility in the compounds list. Another disadvantage is the method cannot be used if dilutions are needed. So the question comes up with this draft 1633 method. Should it be discouraged for initial site characterization if you're not sure what your concentrations are going to be? If you may have high concentrations?
If you expect that you're going to have high concentrations, that's where some of those screening methods can come into play. Okay. And be they 8327 or things like the Piggy or absorbable organic fluorine can help screen samples there and determine, at least as far as a range of concentrations, such that then you could then do further characterization using 1633 or one of the other analytical methods.
Okay. Another question coming in, I'm going to paraphrase this from Richard Rogers. We saw at the initial PFAS awareness a huge problem with laboratory capacity with the methods that we're using now. 1633 is, I think, a relatively new method. How is the lab capacity? Are we going to be able to deal with that? Are enough labs going to use this method that we're not going to run into the same lab capacity issues we are running into even today with all the sites being investigated?
Laboratory capacity will be a challenge because PFAS, as you know, and everything, so is a very hot topic and having lots of analyses performed. But with that said, there are 5 laboratories that are currently certified for 1633. There'll be others coming online. I'm currently working with 8 different commercial laboratories on the multi-lab validation study. And those laboratories will be, well, several of those laboratories are already accredited, and there will be others accredited shortly. And then laboratories have increased capacity since years gone by whenever PFAS first came around. There are laboratories that have capacity of greater than 10,000 samples per month. So at an individual laboratory facility. So some of the large national laboratories have significant capacity.
One of the things that we ran into with PFAS sampling, the actual sample collection early on, was this really big fear of cross-contamination or contamination from just the atmosphere and field around us, and a lot of products. Osaguana, you mentioned in some of your slides references to go to find out.
I think we lost Rick.
Oh, Rick kind of locked up on us, it looks like.
Yeah. I think he was asking for the reference where to go to, and ITRC has a good guidance, like we're talking about. If we're looking at state level, Michigan, if you have a project in Michigan, Michigan Eagle has a very good guidance document that deal with some of these material that you can use and you can stay away from, especially when it comes to some of these sunscreen and bug spray. EPA has some guidance. They have some guidance. So depends on the program that you are working on. Depends on what you are working on. And I'm sure DOD, different parts of DOD have their own specific program. If you're looking at Air National Guard, for example, they have a list of guidance that they can use that you can use for PFAS sampling. So understand the program that you're working on and make sure there are several guidance out there that that deals with what we can use and what we should avoid.
Okay.
Rick, you back. I'm sorry. I think I took it from you and
no, that's fine. It always seems to happen just when I'm asking questions. Like I have that internet glitch on connectivity here. It's a curse I'm bearing, I guess, I suppose. We still have time if anyone wants to type in any more questions. We have a few minutes. Okay, here we go. Question from Steve Pruitt. Can you recommend a reference or tech paper offering high-level info for DoD projects? I'll take a shot at that. You know, one of the things that's interesting about PFAS is that it seems like all the services have their own guidelines. I mean, if you look deep enough, and maybe that's something that we at the Environmental Community of Interest and the PFAS IGE should do. I'll think there's a recommendation that perhaps we should try to, find the latest Army, Navy, and Air Force guidance documents that are being used and post them to the IGE website as reference. This is sometimes problematic because things are constantly changing in PFAS world in terms of guidance. And we're going to get more into that through the rest of this webinar series, like IDW, waste disposal. Another source I'd like to recommend for more information is the ITRC, the Interstate Technology and Regulatory Council. I think most of us on this, a lot of us on this call and presenting this material have been part of that PFAS team. And if you go there, you can download their, they have web-based guidance documents that'll work. We have some links on the ECOI website to like NAVFAC XWIC and Army Corps of Engineers websites. And I think if you go there, Steve, you could find a lot of information on PFAS protocols and sampling. And the projects, for the most part, they're moving from the site investigation to the remedial investigation phase. A lot of sites have had interim actions providing alternate water supply or source soil removal. I'm not sure that's the answer you were looking for, but and you could always email us directly for more information. We've got the you've got the contact information for the presenters of this program, as well as if you go to the ECOI website, you'll find other people who'll be more than happy to try to steer you in the right direction. So, any more questions? Let's see. Okay. Well, I'm going to move to the closing slide, I guess. If someone else has a question coming up, we still have a couple minutes left. But basically, the Society of American Military Engineers has a lot of offerings to members. We have the Small Business Conferences coming up in November of 2022. We've had the JETSI conference, which we just had in May, which had a very large presence of PFAS presentations and papers. And you're welcome to join the Environmental Community of Interest as for networking and getting more information. And if you'd like, we're still looking for people to help us with the PFAS IGE. So unless there's any more, if any of the presenters have a closing remark, feel free.
Yeah, like we said, Rick, we're going to be following this presentation with fast sheets. So some of those references to where some of these guidances are will be on that fast sheet. That will be the next product that will be coming after this presentation, and it's going to be out there on the ECOI website that people can download and use for references. So that's going to be coming after this.
Okay. One more question popped up here from Ramji Raghavan about, is there a safety limit for PFAS? There's health advisories for PFAS that just got released, and some of the states themselves are putting out drinking water standards, but they're all over the place because we're really not fully aware of the toxicology. So like I said, we'll have some fact sheets that you can look to, but I mean, safety limits, I'm assuming you're implying, drinking water standards or things like that. That's an evolving science. And just as we mentioned during this talk, the recent health advisories for some of the compounds have revised, and there's been new ones proposed. And we are expecting a maximum contaminant level MCL under the Safe Drinking Water Act for PFAS. It's part of the Biden administration's PFAS initiative. So I guess the answer to that is stay tuned, and you can even go to EPA.gov and Google, not Google, but go PFAS and find out some information there. John, any closing remarks?
Well, just additionally for the safety limit, there were new EPA RSLs which were issued in May as well. So it established soil limits as
Yeah.
well as soil to groundwater limits. So you may check that out
Right.
as well. But yeah,
Okay.
just in general with PFAS, it's constantly changing and changes quickly. So just advise anyone just to stay tuned for new developments when starting a project. So in particular.
Yeah, and also if you want to understand some of the state standards, there is that ITRC PFAS. They maintain a current spreadsheet. They update periodically. So if you go to ITRC and poke around, you can find out the link to their spreadsheet that summarizes the state drinking water and other standards. A warning, what there may be on the spreadsheet today may not be what is today. This is a very, very evolving area, and could be a lot of confusion. We reached the top of the hour, and on behalf of our presenters and the SAME PFAS IGE project, I want to thank everyone for attending. You may get an email asking you about, polling you as to the presentation. We'd love to hear back from you, and please join us again in the future, and reach out if you have any advice or suggestions for other PFAS topics. Okay, with that, I think I'm going to close it out, and let the folks at the SAME National shut this and the presentation recording. Thank you.